Hello everyone, my name is Nikita and I am from the Bodhi Academy. Today we are going to start an important chapter from 10th Standard Science textbook Goa Board, that is chapter number 12, Electricity. Now before starting the chapter, let us know what is electricity. Electricity is the electrical energy. Okay, it is the most convenient and the most controllable form of energy and the most common form of energy which is used almost everywhere in this time. Now, we need to know some concepts, some important and the main key concepts of electrical energy or electricity. And the first concept which we need to know about is the electric current. Electric current. Now what is this electric current? Electric current constitutes mainly the flow of charges. The flow of electric charges. And over here the charges are the electrons which are negatively charged. There are two types of materials when we discuss electricity. One are the conductors and one are the insulators. Conductors are the ones which allow the flow of electric charges in them. Means it allows the flow of electric current through them and they are called as conductors. And insulators are the ones which do not allow electric charges to flow through them. Means you cannot pass electric current through them. So electric current is nothing but it is the flow of electric charges which are the electrons and which flows through a electric conductor. Now, so this constitutes the electric current. Always the direction of electric current is opposite to the direction of the flow of electric charges. Means if the electrons are flowing in this side, is moving in this side, the flow of current will be opposite, will be on the other side, it will be opposite. So now we need to know the most important concept, like the formula of electric current. Electric current is given by the symbol I. How do we define the formula? I have said that electric current is the flow of charges in that particular time, in that particular area. So charge is given by the symbol Q, okay, and time is given by the symbol T. So the amount of charge flowing through the conductor in time T. Now we need to pay attention to the SI units of all these quantities. We have electric current, we have electric charge and we have time. So what is the SI unit of electric charge? It is given by 1 coulomb. And time is given by 1 second. Okay, and the most important, the current is given by 1 ampere. The very important thing over here is definition of 1 ampere. 1 ampere is defined as the flow of 1 coulomb of charge in 1 second through a conductor. So we can say that 1 ampere of current is flown through a conductor when the 1 coulomb of charge is flowing through the conductor in 1 second. Okay. Now, how do we measure this current? How do we measure this current? The most important instrument, the instrument used to measure electric current is ammeter. Ammeter measures the electric current flowing through a circuit or through a conductor in amperes, okay, and it is connected in series connection with the electrical components. Now what is this series? We will be studying in the later concepts in this chapter. Okay, now the most important questions which are asked in this concept over here is what is define 1 ampere or what is 1 ampere? So we need to know the perfect answer, the perfect definition of 1 ampere. 1 ampere is the current flowing through a conductor, when there's 1 coulomb of charge flowing through the conductor in 1 second. So the words like charge, coulomb, seconds, time, conductor, current are very important while writing this definition. Okay, and also another question which is asked mostly is, which is the instrument used to measure the electric current? And the instrument is ammeter. And in which connection is it connected? It is connected in series. Now when there comes formula, there also comes problems, okay, numericals to solve. So there are some numericals which we need to solve in this concept. Okay, so I will just show one example. Okay, so over here, the first numerical, okay, it says that a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find out the amount of electric charge that flows through the circuit. So we need to understand that whenever a problem is given, we need to first see what is given, which quantities are already given in the question and which quantities we need to find out. So over here, if you pay attention, the current is already given. Current is given, and also the time is given as 10 minutes. And find out the amount of electric charge, means electric charge we need to find out. So current is given, so we will write I equals to 0.5 ampere, right? And it is flowing through the conductor for 10 minutes. So time is given as 10 minutes. T equals to 10 minutes. Okay. Now we need to find out the amount of electric charge. So charge is what we need to find out. So these three quantities, looking at these three quantities, which formula do we apply? We will apply the formula which we have just studied, which is I equals to Q by T. Okay, wherein I is given as 0.5 amperes, Q is not given, so we will write as it is, and time is given as 10 minutes. So here we need to pay attention. I had said when I was explaining the current concept, the formula, that the time is, in this formula, time is given in seconds. Okay, so we need to convert this 10 minutes, this quantity, into seconds. So how do we convert minute to seconds? 1 minute equals to 60 seconds. So 10 minutes multiplied by 60, which will give you 600 seconds. Okay, so here I'll be writing 600. Okay, so here I need to find out the charge. Q will be 0.5. Okay, 0.5 into 600. 0.5, which, because the quantities will get cross multiplied, into 600, which comes to 300. Now, can I write 300 as it is? No, because the charge is given in coulombs, and here I am finding the charge. So I need to always mention the SI unit. So over here the SI unit of charge is coulombs. So my complete answer will be 300 coulombs. If I write only 300, the answer is incomplete. The complete answer over here is 300 coulombs. So this is the answer for this problem. Now we will be doing the second concept of this chapter. Okay, the second concept is electric potential difference. Electric potential difference, which is given by symbol V. Now, I had said that for the current to flow, there should be the flow of electric charges. The charges should flow through the conductor. So what do you think? The charges are flowing by its own? No. For the charges to flow through the conductor, there should be some push movement. There should be something which will make them move, or which will get them into motion. And this concept is electric potential difference. This potential difference is nothing but difference in electric pressure. We have seen that if there's a pipe, okay, and you have to flow water through it, Okay, when you place it in a horizontal position, there will be no water movement. But if you lift it and connect one side to a tank of water, okay, the water will flow because there is difference in pressure. Difference in pressure helps in the movement of water. So same concept we are applying here for the flow of charges. Difference in electric potential. Difference in electric potential means the electric potential difference will make the charges to go in motion, and there will be production of electric current. Now, how do we get the potential difference in an electric circuit? We get the potential difference by the help of battery. Okay, battery is the combination of cells. Yes, so the flow of this concept goes by this. When you connect a battery to the electric circuit, there is a chemical action. There is a chemical action taking place in the circuit. Chemical action which produces an electric, okay, potential difference, which then gets the charges to flow, okay, which then leads to the flow of current. So this is the flow that is followed for the final outcome, that is production of current in the circuit. Now, as we have seen the formula for electric current, there is also a formula for electric potential difference. I have said that the potential difference symbol is V. So the formula goes as V equals to W upon Q. Okay. So V is given the SI unit. Okay. So V is first of all, V is the potential difference. What is W? W is the work done. Work done, and we know that Q is the charge and V is the potential difference. Okay. Now we need to pay attention to the SI unit. The SI unit of work done is given as 1 joules. Okay. And the charge, we have seen that it is given by 1 coulomb. And for potential difference, the SI unit is given by 1 volts. Okay, so we need to now understand the definition of 1 volt, very important. So 1 volt is the potential difference between two ends of a current carrying conductor when 1 joule of work is done in moving the charge of 1 coulomb. Okay, so these words, okay, these scientific terms should come in the answer when it is asked as define 1 volt. So how do you define 1 volt? 1 volt is the potential difference between 2 points in the current carrying conductor when 1 joule of work is done. 1 joule of work is done in moving the charge of 1 coulomb. It's like work is done to move the charge, and that's the reason the charges are moving, and that's the reason we are getting the electric current. Okay, so now we need to see the instrument. So the instrument which is used to measure the potential difference, as in the current, the instrument was ammeter. Over here, the instrument which is used to measure the potential difference is the voltmeter. Voltmeter, which is connected in parallel connection. So there are two types of connection, series and parallel. So this is connected in parallel connection. Now the most important question over here, which is mostly asked, is differentiate between an ammeter and between a voltmeter. So what is the main difference? The main difference, first of all, is it is used to connect the ammeter is used to measure the electric current in amperes, and voltmeter is used to measure the potential difference in volts. The second point of difference is ammeter is connected in series connection with the circuit and voltmeter is connected in parallel connection. Now we will see one problem based on this formula. Okay, the second one. So the problem reads like, how much work is done, how much work, okay, how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts. So as I have already said, we need to first pay attention to what is already given. So here the quantities which are given are charge, means Q, charge, right? Charge, Q is 2 coulombs, and the potential difference, which is V, is 12 volts. Okay, we need to find out how much work. So we need to find out the work, W. Okay, so looking at these three quantities, which formula do we apply over here? The formula which we have just studied, which is V equals to W upon Q. Now what is given is, V is given as 12 volts. W is not given, so we write it as it is, and Q is given as 2 coulombs. Okay, so how do I find this? I have to cross multiply 12 and 2. So work done will be equals to 12 into 2, sorry, 2, which is equals to 24. Okay, so now what is missing over here? Is it complete? No. The answer is not complete because we need to write the SI unit of work, which is joules. So the final and the complete answer will be 24 joules. Okay, so this was one example of the potential difference problem. So today in electricity chapter we saw two concepts, which were the electric current and electric potential difference. And in the next class we will be covering the next concepts of the electricity chapter, and we will be solving more problems. Okay, so thank you for watching my video. Please like, share and subscribe.